Hi everyone, I'm MK. Welcome to my channel. We have another problem of LeetCode daily challenge. We have also a great quote from Master Ugwe, which he says to Shifu that you must believe. And if you don't know these two great characters, go on and search about them. They are masters. Okay, so today's problem is marked medium, but it's not medium. If you read the problem, you will probably agree that this is an easy problem. Let's read it. We have a string S, and it's consisting only of characters A, B, and C, and we are asked to apply the following algorithm. Okay, a number of times. We should pick a prefix of the string that is non-empty, okay, and all of the characters of that prefix should be equal. We should do the same for suffix, and again, all of the characters should be equal. The prefix and the suffix should not intersect at any index, okay, so they should not share any characters. The characters from the prefix and suffix must be the same. So if prefix is A, for example, the suffix should be A, something. So both of them should have the same character. And if all of these conditions, are met, we can delete both the prefix and the suffix. And the final goal of this problem is to minimize the length of S. We should, after performing any number of operations, any number of times, possibly zero, we should return the length. I think I have mentioned this before, that whenever the problem looks like you should have some optimal strategy, that you should play a game maybe, or there are some choices to be made along the way to solve a problem, to solve an example, always look at the examples. If you don't come up with your own examples, at least check the examples meticulously. Okay, let's go and take a look at the examples. So this is the first example, CA. So we take the prefix, which is C, and we can extend the prefix as long as it's the same character. So C, that's it. And we have a suffix A. They are not made of the same character, so we are done. That's it. The answer is 2. We just return it. The next one, CC. Okay, we just get rid of them. What is happening here is that we don't have any other option. What else do you want to do? To this problem, not in your life. You pick a prefix and you pick a suffix, and you extend the prefix as far as you can, and you extend the suffix as far as you can, as long as you can, and then you get rid of them. This is the optimal strategy because you want to minimize the length of input. That's it. And then you move on and solve the rest of the problem. So here we have A. You get rid of them. Then you have B and B again, and then you have A and A again. So the answer here is 0. This one, you have A and A. So you extend as much as you can, and then you get rid of them. Here, you have B and you have BB. So you get rid of them. And then you have this one, which you cannot do anything about. So there is a boundary case for this one if your input is only one character. That's it. You cannot do anything about it because prefix and suffix should not share a character. Yeah. And if at some point in your algorithm you end up having only one character, again, you cannot do anything about it. And that's it. So how do we solve this problem? We can have 2 pointers, one to the beginning, one to the end. We extend this pointer as much as we can, and we extend this pointer as much as we can, and then we get rid of the prefix and the suffix if they are the same character. And then we do the same, Each time we should just make sure that at least 2 characters are still remaining. That's it. Let's go and see how we can solve this problem. How we can write the code, Okay, so we have some I, which is pointing to the beginning of the string, and we have some J, which is pointing to the end of the string. Okay, and while I is less than J, I less than j means we have at least 2 characters. Okay, the start is si, okay, and the end character is sj. So if start and end are not equal, we can break. We can just break out of the while loop. We are done. We cannot do anything else because they are not equal. Otherwise, we extend I. So while I is less than or equal to j and s of I is equal to start, I plus plus. Okay, and while j is greater than or equal to I and s of j is equal to end or start j minus minus. So this is how we extend. We move I forward as much as we can, and we move j backward as much as we can. And do we need to do anything else here? No, I don't think so. And then here we just return j minus I plus 1. Let's have an example for this. Let's say we have a b a. Okay, what happens to I? I will become 1 after finish, right? And j will become 1 after we are done, right? So it's going to be j minus I plus 1. That's how I figured that out. Let's see if it's correct. Yep, let's submit. Okay. I'm going to come up with a variation for this problem. Give me a second. So this is the variation. So we still want to minimize the length of input. That is still our goal, but with the maximum number of operations, with the maximum number of moves. So here, for example, we can get rid of A and A. This is going to be our first move. And then we can get rid of A, and A. This is going to be our second move. So we can do this in 2 moves instead of 1 move. Remember, we could do it in 1 move, which was A, B, A. We could just get rid of both of them in 1 move. So the question here is, what is the maximum number of moves you can make to minimize the length of input? This is one variation. You can come up with some other variations along the same narrative. Like, think about counting problems, for example. How many different strings you can make, and so on and so forth. I don't want to give you another variation. I just want to give you a hint of how to come up with other variations. If you have any questions, please ask me in the comment, and please do subscribe if you haven't done already, and introduce me to your friends if you like. Thank you, or don't. Bye.